Yeah. So now, okay. So yeah, yeah. Let us go. How actually we control the speed. So one of this method is called changing the pulse width. But we do it with this. These are the thing we adjust it with a potentiometer, analog potentiometer. So analog potentiometer is kind of like that. You can see that. So it is a variable resistor. Okay, potentiometer, you know it, electronics. Potentiometer is like a variable resistor. For example, this is 5 volt, and output is taking from here. Okay, so we can change the resistor. This R, it is a variable resistor. So for example, we are at this point, so the voltage is minimum. Then we are going up, and if we take the output from here, it will be the maximum 5 volt. Okay, and if it is from here, so output voltage will be 0 volt, because this point is connected to the ground, 0 volt. So anyway, so this is the analog potentiometer. If voltage is low, what is the idea, or how can we adjust this output of this potentiometer with the speed control? So what actually we want that if output voltage is low, then motor should speed is low. So that means off time is more. Off time of a period is more than on time. Okay, and if voltage is high, then on time is higher than off time. On time will be, if voltage is the maximum voltage, that means it operates as a maximum speed, and at that time off time is minimum compared to the off time, on time. All right, so let us have a look here. See, it's details about what is the voltage, how many voltage level. So you know, this is the analog. So as it is a potentiometer is analog data. So analog data, how can we get the analog to DC converter? You know, this idea is same as the last experiment we discussed, and also it came to the lab final exam. How can we read the ADC data? How can we read the ADC data? What is the algorithm? This is all, you know it. First of all, read a data. If, for example, value 1, and if it is connected to the port A, so port A, it doesn't matter. For example, this potentiometer, this analog to DC converter output, it is connected to the port A. Read port A, and this value is value 1. Save it. So save this value 1. Then read again. So this time gap is very low, like microsecond. It's almost same. So then it read the value 2 or data 2, and check that they are same or not. Compare the two values. If value 1 equal value 2, is it yes? If yes, then okay, fine, our data is accepted. If it is not, then again, so data is not accepted, it again read the data, again do the process. This is the analog to digital data reading process subprogram. We already discussed it in the in a previous experiment. Okay, so same idea, we will use it for same subprogram. We will use it, analog to digital converter. Now whole program, what is the flowchart for whole program? It's first of all initialization, turn on the motor. It is delay for 10 milliseconds. I think make the turn off first. Make the off, not on first. Turn off the motor, and yes, turn off the motor first. So turn off the motor first, and for example, your delay is 20 millisecond. Sorry, T is 20 millisecond, for example. T, total period of the pulse, is 20 millisecond. Okay, and the motor is off. Motor is off, and make it delay for yeah, make it yeah. So turn off the motor. Okay, I think yeah, no need. Yeah, no. So this one we don't need it now. Okay, so yeah, this is also a, but I think other way also we can turn off the motor. First of all, turn off the motor. Read ADC data. Now potential analog data. Analog data, the potentiometer data, is it low or high? So first of all, this value, the value, you should scale it down by 13 to adjust it. Okay, so like during the light brightness control, we scale it down by 16, 16 or some value. Okay, so here it is by 13, divided by 13. Okay, and then this 13, if it is divided by 13, and then if this value we have to yeah, and then the table, we have a table, the table has a off time data period, off time period. I mean, in a period, what is the off time? For example, out of 20 millisecond, what is the maximum off time? Maximum off time, for example, 10 millisecond. 10. Then it is 9. Then it is 8. Then it is 7. Then it is 6 until for example 1, not 0, 1 until 1, for example. We can also make 0. So for example, how many data? For 1 to 10, 1, 2, 3, 4, so 10 data, for example. So these are the off time, for off time. Okay, so first of all, yeah, load the offset of the table. So what is the offset address of this one? We know it, how to do it. And then add this scale value, I mean the ADC value with this offset. So if ADC value is the minimum, if the ADC value is minimum, that means we want the speed minimum. That means this is the maximum of time, is maximum of time of a period we want it, of a pulse, like this one is the pulse, right? So off time, this is the off time. The total period is fixed 20 millisecond. If off time is the maximum off time is 10 millisecond. So that means if ADC value is the minimum, then we want is 10 millisecond off time. So what will be the on time? 20 minus this 10, it will be 10 millisecond. Then if it is not minimum, a little bit more than minimum for analog to potentiometer value or ADC value, then we want 9. So if off time is, so on off time will be a little bit bigger. So on time will be 20 minus 9. On time will be, sorry, on time will be higher, 11 millisecond. So this is the way we control it. So now okay. So more, yeah. So then we add the scale down value of ADC to the offset table, and then load the delay value from the table. So we know the subprogram, we know the delay subprogram, like this is the delay subprogram. The delay subprogram for 1 millisecond. So we make a delay subprogram for 1 millisecond. We have a delay subprogram for 1 millisecond, for example. And motor is off. At the beginning, motor is off. So then we load this value, and for example, this value is 10. So for 10 millisecond, motor is off. Then what will be the on time? 20 minus this 10 millisecond. It will be on time will be 10 milliseconds. Then turn on the motor. This one is on. Turn on the motor and make it for 20 minus this off time. That means 10 millisecond here. and implement the delay. Again, for a certain time, it will be on. So this is the way it will work. So idea is this is the logic, program logic for speed control. Is the idea is okay? Okay, so if it is done, then let us write a look at here the table db10. You can write it in a hexadecimal number or 10. You can write it just 10, 9, and until 1. Okay, so let us write the program now. Okay, so so what is the control word here actually? Okay, so control word is the control word here. The analog potentiometer, it is connected in a port A, and motor is connected in port B. Port B, 6 and 7, bit number 6 and 7. Okay, so it is like that. Let me draw it here. So the hardware connection is simple connection is like that. This is for example 8255. Okay, so port B, bit 6 and 7, they are connected to the motor, and yeah, and port A, it is connected to the ADC, analog to digital converter, and a potentiometer analog data is connected to the ADC. Input of the ADC is analog potentiometer, and output of this data is digital data. It is connected to the port A. And so what will be the control word? This is for port C lower, it is don't care. And this is for port B, it is output. And this one is for mod 0. And this one is for port C upper, it is don't care. And this is for port A, it is input. And this 2 bit is 0, 0 for mod. And this one is 1. So what will be the control word? It is 9, 0, 90H. Yeah, yes. So 90H or 99H. 99H. Okay. So yeah, both are okay. So yeah, so ADC is definitely is analog data. Yeah, input port. Port A is an input port because analog to digital data. So potentiometer data, it is converted to digital data. Uh, uh, yeah, to be read by the 8255 IC, okay, or microprocessor, because my yeah, through the port 8255 port A. Okay, so it is 90, yeah, so like that. So now what will be our program? Move L comma 90H out control register AL. So control word is sent to the control register. Now it's about so this is now the beginning of the program. Start all ADC, all A B C ADC. Before that, we can make the okay. First of all, we turn off the motor. Okay. Let us write. This, this is the start. Will okay. So let us write the table and other thing first. Table is L table. So DB 10, DB 9. We can write them also in a one line instead of many line. We can write them in a one line. Okay, so so that means no need of separate line. We can write it here. 9, 8, sorry, comma, we need a comma, 7, 6, 5, 4, 3, 2, 1. So instead of 9 or 10 line, we can write them in one line. Doesn't matter. Okay, so and end. Last line is end. Okay, end. And before that, we have to use a delay subprogram for 1 millisecond delay. So delay subprogram. So out of the move cx, comma, you can remember for 1 millisecond 273, and for 100 millisecond 27,300. So 273 for the machine, for the I mean the machine that we use. Okay, and then uh, increment cx ramp not 0. Okay, so this is for 1 millisecond, but if we need more than that, like 10 millisecond, we need another loop outside of this loop. Okay, so so we need a space for this one. Okay, so outside this loop, we need another resistor BL. Okay, so decrement BL, decrement BL, jump not 0, delay. Okay, so one more line we need. Okay, okay, then need the return. Okay, return. So this is the return. So not jump start, because it when actually it is a subprogram, when we call it, then it will back to the next line. Okay, so yeah, it will go to the main program, but okay, this is the delay subprogram for 1 millisecond. All right. Now motor on. Okay, so first of all, we keep the motor off, and you know that motor off, motor is connected to the port B. All the bits are off, then motor is off. So start. So make the motor off. Move AL, comma 00H, out port B, comma AL. So that means motor is off. So it means motor off. Motor off. But uh, for how many for what time? It's about this delay table. We should take that, take this value for 10 milliseconds. This is the off time. The table is for off time. So motor is off, but for how many seconds? Just instantly, or for a certain time? For a certain time. So 10 millisecond off time. So then actually we have to, that means now it's about, we have to and also this off time, we say that we control the off time. Total period is fixed. We control the off time, then on time will be automatically change, because on time is total time, total period t minus off time. So so that means now it's about yeah, yeah, ADC data, call ADC. So we call the ADC subprogram, and then yeah, so ADC subprogram. So now you know that ADC value we get it in port A. I mean through the port A we call it. We will write, okay, so ADC subprogram. We have to write the ADC subprogram here. Yeah, ADC. What is the ADC subprogram? In AL, comma. So ADC is connected to port A, right? AL, comma, port A. So this is the value 1. We save it in move BL, comma, AL. So that means this value 1 is saved in BL register. All right. And then we read again. Okay. So that means it is value 2. Now we compare AL, comma, BL. Are they equal or not? This, so the value 1 and value 2, they are equal or not? And if it is not equal, so if it is jump not equal, if they are not equal, go to the ADC again. Go to the ADC again. But if it is equal, so we have to make a space. Okay, if it is equal, then what actually do? If it is they are equal, that means this, yeah, AL value it is accepted. So then that means we will go back to the program. Okay, so return. Yeah, return. It will come to the main program. Now, so is it okay? This subprogram is clear. This ADC subprogram is clear. This is the ADC subprogram. Is it clear? ADC subprogram. Yeah. So yesterday actually during the exam time, it came like that. Yeah, write the ADC subprogram. Just only ADC subprogram. This is the main thing. So main idea is it is done here. Okay. All right. So then what? Okay, different ink. Not, yeah, this one we can use. Now call ADC. So ADC now our ADC data is in AL. Okay, ADC data in AL register. So now so this data will scale it down. We have to scale it down. Scale it down by what? In the algorithm, what is the scale down? I think 13 divided by 13. Okay, move EL, comma 13. And so ADC value is in AL. So move AH, comma 0. So that we make AX. Now divide BL. Okay, that means AX is divided by, so AL has AX divided by 13, right? This is the X table. So it is the scale down ADC value. All right. So scale down ADC value. Now we adjust. We also need the offset of this table. What is the offset address? No. SI, comma. Okay. I think maybe we can use dx, comma offset table. Okay. And then so offset table, and then so then add scale down value of ADC is in AL, right? add al at at ax, because ax comma ex, or okay, so I think maybe we can use the si here. Si, and then at si comma x. So that means, so now we'll get yeah, si is the offset. Yeah, si has the offset of the table. So this offset of the table we have to adjust it with the adc value. Adc value, scale down adc value. Is it the minimum? If it is minimum, then so that means minimum means, for example, 0. So 0 plus this offset, it will be that 10. And so 0 plus 1, it will be I mean offset plus adc scale down value is 1, you will get the 9. Offset plus adc value 2, you will get the 8. It is so on. So that means now yeah, so this is our, we make it addition. So then bl comma square bracket si. So that means this 10 or 9, whatever it is, it will come up here in bl. So now call delay, because delay we use the bl register for a multiple of the 1 millisecond. Call delay, call delay, call delay. So that means now it is a certain time, 10 millisecond, 9 millisecond, what is the, it is off, motor is off. So what is the period now? Move move for example, what are the resistor move okay, so move al dx, we already use the, okay, we do not use the dx. Okay, move dx, not dx, because we use the bl. Okay, bl for this 10 or off time, so move dl for, or not dl, okay, dl, move dl comma 20. Okay, and then sub sub dl dl comma bl, bl comma bl. So that means we will get the on time, it is in dl. Okay, and so we first, okay, so we have to make the motor on now. So motor on, so that means first of all we can make the motor on here. How can we make the motor on? Just yeah, yeah. So motor on, so move al comma motor on. So that means any, so like 7 bit is 1 and all the bits is 0. So that means 80h. If you send 80h, motor is on. All right, and out port B comma yeah. So motor is on. Now for what is the on time? We are calculating it. We know that this is the total time. This is the total time T equal 20 millisecond, for example. Okay, this is the total time. Or 20 millisecond. Now we sub TL comma EL and BL 20 and then send it to the BL. Move BL comma BL. So that means BL is now this T minus the off time, T minus T off, T on time, and then call delay again. Call delay. That's it. So call delay, that means that motor is on now for this millisecond. Okay, so motor is off. Here motor is off. Motor is on. Okay, call delay. So and then jump start. Again and again. Is that okay? Clear? So this is the I mean simple way. Yeah. I mean yeah. This is the program that actually to control the speed of a DC motor by analog potentiometer. So hopefully it is clear, right? This is our delay subprogram. Any question do you have here? Okay, now it's about finish the project. It's about finish the project and do you have in okay for the quiz today? So I will put the time for quiz today from 10 a.m. to 10 a.m. Sorry, 10 p.m. 10 p.m. to 11 p.m. 10 p.m. to 12 p.m. It is okay, or you want it in the morning? Hmm? You have lecture at 10. Okay, 10 to 11 you have a lecture. So what about? Okay, so I think probably I can put the time from midnight. Midnight what time? 12. You mean 12 a.m. until 12 a.m. Okay, so no problem. I will put a long gap, a long duration. I will put it. So yeah, I'll put a long duration. Okay, so this one is okay, right? I can erase it. All right. Clear? Okay, so let us clear all the things. So finish the project, okay, as a group. Finish the project and send the report send the report with details. You look at the manual, lab manual, and make a report and send it to me by this week. Because I have to finalize. Don't go to the next week. Next week is for final exam, so you should not disturb your final exam with other job. So finish this week. Give some extra time and finish this thing by this week. Okay. So this is about the project. Okay. Now let me clear it. Final exam. So I will again revise the final exam. So look, this one is not the same as the what we actually discuss now about the project. DC motor switch by switch, like to switch, motor is off, motor is forward movement, backward movement. It's like that. Yeah. So don't confuse this thing. So this project is a bigger one. It's not part of the final exam. Okay, so look at here. So let me finish. Okay. Then. Okay, so this is all about the final exam. Uh, if you look at here, so final exam, yeah, so the final exam. So input output interfacing in 8255 IC. Here you have 3 programs. Okay, and then microcomputer system. Here you have 2 timing diagram, but not 2 actually. Here actually 4. So if it is memory or input output read operation, or memory or input output write operation, so it becomes actually 4. So I already discussed it in the class, so make it. And what is the function of this control signal? 4 here, 5 control signal. Okay, so this is for microcomputer system. And then from homework 2 and 3, there are many programs. So programs for finding minimum, maximum, and average. Okay, so and then machine code, finding the machine code. So yeah, this is all about the final exam question pattern. All right, so if there is any change, I will announce it on the blackboard. Follow the blackboard announcement. So hopefully it is like that. Okay, so yeah, so time is 1 hour 45 minutes. So definitely we cannot put many questions here. So you know the exam is on 25th, 25 of April, and it is from 9 to 10:45. So exam is 1 hour 45 minutes. So question, I mean, we cannot put a lot. I mean, we cannot put many questions there. So it is kind of like that. Okay. So do you have a question here? Until now it is. Okay, so until now it is, but if there is any change, I will announce it on the blackboard. Okay. No, stepper motor is not lab 9. There is nothing on the stepper motor on. It's not lab line. It's actually in a lecture class. These are the things we discuss in the lecture class, not a lecture class. Yeah, stepper motor. It's not from the experiment because we do not do any experiment based on stepper motor. Okay, so do you have any other question? All right, so Ramadan Kareem for everybody, and wish you all the best for the final, and yeah, and good luck for you for the final, and wish you a happy ending of the semester. Okay, so stay safe, and if it is physical, then we will see you in during the exam time. Otherwise, that's all for today. Okay. Yes, yes. Report. If you have any report left, send me on email as soon as possible by this week, because I will finalize everything by this week. So don't go beyond this week. And other thing is, let me finish. Other thing is there is a survey. I remind you yesterday survey. If you do not finish the survey, you will not get the marks out of 70. Before the final, I will announce it on the blackboard out of 70 how much you have. So, but if you do not submit the survey, if you do not complete the survey, you will not get it. Okay, so finish the survey. It is the part of the I mean course ending. So I mean don't miss it. Okay, all of you. Okay, you should finish it, and you should also remind your friends. Okay, remind your friends who you working together. Like today, actually, I can see only 8 of you are here. So this is not all. So everybody should remind at least 3 or 4%. Okay, so I wish all of you complete the survey. All right. Okay, so Mukbil, now tell me what you want. Mukbil?
Teacher,
Yes, teacher.
tomorrow, tomorrow I have a final lab for 340. If I am ready, I will come to your office to take the mid lab exam.
Tomorrow what time, Mukbil?
If I am ready, I will come at 12 for you.
12?
Yes.
Yeah, 12 noon. I mean 12 p.m.
Yes, yes.
Okay, okay, no problem. So it's around the Johor time. So the whole time is okay. Yeah.
Yes.
So I mean, just for I mean, I'm thinking about that. Yeah, I will be available. No problem. So come and attend. At least attend. Show me your face. Attend
Okay.
and write this basic thing. Basic thing. I hope you should you should know it. Basic thing. It's not like full marks you may get. At least instead of 0, you should get some marks that
That's
help
right.
you out of. Yeah. So don't miss it. Okay. Okay. See you tomorrow, inshallah.
Inshallah.
Okay. Inshallah. So
Teacher,
any other question? Yes. Yes.
if I am not ready, I will come at Thursday. Are you okay with that or what?
Thursday, no problem. Thursday also office day. I am okay. I am okay.
Okay.
Just let me know. Let me know before you come. Just give me an email. You know my email address.
Yes.
Send me an email. That is fine. No problem.
Okay.
Any day. You just let me know.
Okay. Thank you, teacher.
Okay. Welcome. All right. So that's all for today, right?